Welcome to this course, Business Analytics. In this tutorial, I will help you build a simple linear regression model on Python. We will use the same dataset which was discussed in the course lecture. Let's start. First, we will start our Jupyter Notebook. So I will be using Jupyter Notebook. I will be using this folder location to do all the operations. So okay, Jupyter Notebook. Now I'll create one notepad file, Python 3. I'll give it a name, say SLR model. Okay. Before we start the coding part, let's identify what are the building blocks of this model. First, we need to import relevant data and pre-process and prepare those data to be used for the modeling exercise. So we will create one markdown cell, markdown, or in shortcut you can put escape m. Okay, so here we will do import data and prepare. Okay. And second step will be will fit a simple linear regression model to this data. Okay, escape m. Then we will put fitting a SLR model. Okay. And finally we will be showing the output of this model. Okay, then again escape m, put output. Now in Python we also need to import a relevant libraries, and that is the first block of this code. Okay, so escape above, then escape below. So to insert a new column, above the cell is escape A, if below escape B. Okay, now import relevant libraries. Now what are the libraries relevant for us? For working on the data preparation, we will be needing Pandas. Pandas is similar to your Excel notebook, Excel spreadsheet. So whatever the functionalities Excel spreadsheet has, those things you can use, you can do in with Pandas libraries. Okay, so we will, and next is for building the model, we need to work on these arrays like x and y as a response variable and the predictor variables. For that we will need numpy. And third, we will need a library for visualization, for example to plot the scatter plot. Okay, so we'll need this matplotlib for that. So we will import pandas as pd. This pd is the alias for pandas. Okay, if we don't use pd, every time we have to keep writing pandas dot something, pandas dot something else, like that. So it's the pandas. We can use pd dot, say, create data frame, pd dot read csv, so on. mp import matplotlib dot pyplot as plt. And next thing is that whatever the visualization we will be creating on matplotlib, it should be displayed inline. It should not create a pop-up. So we use %matplotlib inline. Alright. Now next we will import the data. So this is our data headers. This is in CSV format. So we'll be importing that. So we'll create an instance for pandas. Df is equal to pandas dot read csv, and we will be needing this folder location. Here one important thing, in the address line it has this backslash, but in Python they only consider this front slash. Okay, so we have to change this thing. Our Then we'll have our folder name heaters 1.csv. Now we want to print that. So this is your file, but remember one thing. Since we have only 30 rows, so displaying this data is not a problem. But when you are working with big data, displaying the entire data frame will be problematic. Your system will hang if occupy a lot of space. So that's why we use to display. We just want to see how my data looks like on this data frame. So for that we can just print first 5 or 10 rows. So we will use this head function. By default it will print only 5 rows. Okay, if you want to print first 10 rows, then just put 10. All right, next. Yeah, so next we have to demarcate what is my response variable, what is my predictor variable. Okay, so we have to mark the response variable and the predictor, which is my x. To do that, we'll put x is equal to, from this data frame we have this price is my predictor. So this is the first column. In Python the column number starts from 0, so it is not 1 2 3 4, it is 0 1 2 3. So in column first means in Python is column number 0. So df dot illocate all rows and first column, and we need the values in that column. Similarly, my response variable is df dot illocate all rows and the second column. So one dot values. So I can put x, y will print. Okay, so we have two arrays. Next, we want to we want to see the scatter plot whether we have a linear pattern or not. If we don't have a linear pattern, then we cannot use simple linear regression model. We don't need transformation. What is transformation? That you will learn in week 5. Now we need to check whether there is a linear pattern between x, y. Okay, for that we will be using matplotlib. So plt, you can see this pyplot. PLT already we have marked as a PLT, matplotlib that pyplot. So we'll be creating one scatter plot from there. Now PLT dot, for shortcut you can put def. You have all the function available in the PLT is available to you. So we use scatter plot. Yeah, scatter. So we need x and y. Okay, this is your scatter plot matrix. So here one observation you might have, this is not entirely a linear pattern per se. It's showing linear pattern also. You might also argue this is actually cortical pattern. So yeah, in practice you won't be having a well behaving data which exactly follow a linear pattern. So what you can do, if you're not satisfied with that linear pattern, you can actually transform the data so that it looks like linear. So the transformation, I won't go deep into that, but I'll give you a short overview of this transformation later in the second part of this tutorial. All right. So right now we'll just simply fit a simple linear regression model like how Sir did in his lecture. Now next is fitting a simple linear regression model. Now, if you have a single feature, you have to reshape your x to -1 to 1. This is a required. I think it is for indexing purpose. You can search over Google why this is required. Otherwise, it will show error. So, first is reshape your data using array dot reshape -1 1. Okay, if your data has one feature. Okay, that I will show you. So to fit the model, we need to import scikit-learn. So those that scikit-learn will import here in the import relevant libraries. Okay, from sklearn dot linear model import linear regression. Linear regression. Okay, now this is my one functionality, one method, one object. Sorry. Now we'll create an instance. Say regressor is equal to regression this. We have created one instance. Okay, we have created one instance. Now for this instance, with this instance, we will fit our model x and our data x and y to build a model. So regressor dot fit will fitting x and y. Again, we mentioned that you have to use this reshape for x. X is your feature. Okay, once you now my model is ready. Okay, okay, sorry, we have now run this code. Now we can put all right, linear regression. Now we will display the output. Output is coefficient, intercept, and r square. Three things we need to put. So we will put print regression dot coefficient. Then we'll put regressor dot intercept. Okay, you can verify whether these values are matching search values or not. Okay, so finally we need to print the r square value. Now for r square value, again we have to import the relevant library for it. Now this r square value again is on scikit-learn. We have to import that r square functionality from sklearn dot matrix import r to score r to score. Okay, run it. Now to print the r square value, we need two things. First is your actual observed y, and another is the predicted y. So predicted y comes from our model which we have built just now. You have to pass on the x value, then from this model and the x value, what my predicted y value is. Okay, so y pred is equal to regressor dot predict x dot reshape. Okay, so we can print what y pred is. These are y predicted values. Now my R2 score will be between y and y pred. This is my R square value. You can match whether this is the same as what sir is found. Okay, so this is a simple linear regression model. Now we will move on to the second part. In the second part, we will discuss briefly about transformation. So for that, we come to this scatter plot matrix. I have previously mentioned that you can also argue that this is a slightly curvical pattern. So in this case, what I can do to make it a linear so that I can improve my model accuracy. But remember, transformation not necessarily always increase your R square value because it might not be required. And also you have proper guidelines like what kind of transformation you should use for a particular pattern. That will be discussed in a week 5. Okay, so here it is like you have to take help of Tukey circle, which is discussed in week 5. Okay, so we will be using some transformation here. Before we go for transformation, I'll just demonstrate what is the effect of a transformation. Okay, so this is your data. You can see we'll plot a scatter plot matrix. This is your original scatter plot matrix. So we will fit a trend line here. Okay, form a trend line. We'll display equation on chart R square value. Okay, this is my original stuff. Now say I want to put a square root of y, square root demand is equal to sqrt demand Now if we plot a scatter plot between these two columns, you could see now it is a lot better. Okay, just put one trend line here. Equation, form a trend line, display equation on chart and display R square value. Now if we compare these two, R square value has improved. But remember again one thing, improve R square value not necessarily always be the better fit. You have some other factors need to be accounted for. But here, since the pattern is bit better compared to the first one, the R square value is improved. Okay. Now we use this transformation here. Now what transformation we'll use? We give a y new is equal to np dot sqrt y. We put y new. Okay, this is my square root value. Now we'll build this model again. We'll see what my R square value is. Okay, we'll give a new name, regressor 1. Regressor 1, will put it as a y new. Regressor 1, y bread 1, y new, y bread 1. Okay, y bread 1. Yeah, now you can compare what is this data is matching whatever I just now I have showed you. And you can see the R-square value has improved. Okay, so this is your transformation. Again, I am not going in detail of transformation, and this thing will be discussed in detail in week 5. And last part, I will just show you how in practice a machine learning model is deployed. When you want to build a model with a big data, you split the data into two parts, training and testing. You build a model on the training set and will predict the test set. So then you'll find how accurate your model is. So here we'll do a split. Now again the print is split. We have to get the functionality from a scalar. So we will demonstrate here train test split. For that again we have to import the relevant functionality from the scalar. Okay, so we have from scalar dot model selection import train test split. Okay, then we create 5 arrays and from this functionality. So we have x train, x test, y train, y test is equal to train test split. Then we have x reshape and we have under is y. And how much we'll create 20% as a testing data. So we'll have test size is equal to 0.2 and we have random label pick this data at the 0. Okay, now we have y bread is equal to, we create a model. Now we'll define now we'll define a model fit is equal to linear regression, then model fit dot fit x train and y train. We'll build a model based on this data set. Then we will predict x test to get y predict. Y predict is equal to model dot fit dot predict, will predict x test. Okay, then we have y predict. Now Now it display the R square value. R to square on Y test and Y breadth. You have now you can see the R square value has come down. This is because we have just 20% of 30 data points. That is 6 data points. More data points, more accurate your model will be, and in practice we'll have millions of data and your model accuracy will be improved. Okay, so that's all for today. If you have any doubt, you can put it on the Discord forum and ping me. Thank you.